welcome again to my channel and wish you a very good morning. Today we are going to solve another question which is 1296 of Leetcode and it is marked medium. Given an array of integers nums and a positive integer k, so we are given two inputs, an array of numbers which is nums and another integer k, right? Check whether it is possible to divide this array into sets of k consecutive numbers. That means we have to divide the given array into different subarrays, and the numbers in the subarrays must be consecutive, like 1 2 3 4 5 6 in that fashion, right? Also, the length of each subarray will be k, which is the given value, right? Length of each subarray must be equal to k. Return true if possible, otherwise return false. Okay, now so actually I'm re-recording this video, that's why everything is already written out. I forgot to turn on the audio, so I have to record it again, but I'm not deleting everything, I'll just explain it from the start. Okay, as you can see, I've taken this array and the value k equal to 4, right? We'll run a for loop, which is I, and we'll start from 0, of course. So what will we do? We'll keep a frequency map, right, which stores the count of each numbers, and then in the loop we will check if we can start a subarray from that particular number. That's a very important logic or pointer for this question. Also, if you have seen the previous video I posted yesterday, right, uh, you will find it very similar to this question, right? And it will be very easy for you to understand this particular question. Okay, so you can check it out and then come again to this video. But the logic is essentially the same as the previous video. We are keeping a frequency map and we are iterating over the array. Now for any particular index I, right, for the value of that ith index, in the previous video what we did was we tried to include the number to an existing subarray or subsequence, right? But in this particular video there's a difference in that logic, that we are trying to start a new subarray for every number we find, if it's available, of course. If it's not, then we continue. Otherwise, we try to start a new subarray. So let's see what this means. So I'm currently on 1, right? I'll check if 1 is available. Okay, I'll just remove these then, right? Currently I'm on 1 and I'll check if 1 is available. As you can see, 1 is available, so I'll reduce it to a 0, that I have used up 1. Now since 1 is available, we are going to check if the next consecutive numbers of 1 are also available. And how much? Let's say this is 4, right? We are going to check if the next 3 numbers are available. So whatever the k is, minus 1, k minus 1, right? Whatever the k is, so let's say 4, we are going to check if the next 3 numbers are available. Why? Because the number that we're currently on is also part of the subarray. That's why including that number it will become 4. So that's why we are checking the next 3 numbers. So as you can see, the next 3 numbers are available, 2 3 4, right? So we'll reduce each of them by 1. This becomes 0, this becomes 1, and this becomes 1, right? Now we have made this subarray, so we can move forward. Now I comes to 2, right? It checks for its availability. Is 2 available to make a new subarray starting with 2? And we see that 2 is not available, so we move forward. We arrive at 3. We check if 3 is available to start a new subarray with, right? And we see that 3 is available, so we reduce that to 0, right? And we check the next 3 numbers again, 4 5 and 6. Those are also available, so we'll reduce them as well. And now everything has turned into this. everything has become 0. So we move forward, we have made the new array with 3. We move forward, we again reach 3 and we check it is available or not. It is not. We move forward. We check is 4 available or not. It is not. We move forward and continue like that because nothing is available and we reach the end of the loop. If we reach the end of the loop, we return true, because if we were to return false, we would have done so in between the loop somewhere. If somewhere we found a number with which we could not start a new subarray, right? If we could not start a new subarray with the current number, we would have returned false then and there. If it's not the case and we reach the end of the loop, we'll return true. So it's a very pretty easy logic. I urge you to see the previous video, which whose logic was a bit harder. So it was a bit difficult. So it will make it easier for you to understand this. Um, yeah, let's get to coding. And okay, so we are going to create a frequency map and we are going to fill it. So for score num range nums frequency of num plus plus, right? Now then we are going to run another loop for underscore num, and for every step we are going to check if the current number is available or not. So if frequency of the current number is greater than 0, or we'll do is equal to 0, that means it is not available, and we'll continue, right? We cannot use this current number, so we'll continue. Okay, if it is available, we'll bypass this block and reach at this point, right? So at this point we know the number is available. We just need to make sure the next 3 or 4 or 5 or 2, whatever the value of k is according to that, those numbers are also available, right? Because we want the numbers in the sub arrays to be consecutive, right? If you can see here, numbers are all consecutive. So we'll start a for loop here as well. So for I equal to 1, I'll explain the logic of all this. The for loop I less than equal to k minus 1 I plus plus. Okay, so generally we start I from 0, right? But here we have started with 1. Why is that? Because this for loop is not for just running running like 3 times or 4 times. We also need to use the I in a specific way, which is to find the next numbers. That means in the first step, imagine we are at 1, right? Imagine we are at 1, and at 1 we are running the loop, the inner loop, for the first time, right? If we are running the inner loop for the first time, that means we are just searching for the next number. And what is the next number? The next number is the current number, which is 1 plus 1 plus 1, right? That means that's why the first the value of I starts with 1, because to find the next number we have to add it by 1. In the next loop it will become 1 plus, it will become 1 plus 2, right? Then in the third loop it will become 1 plus 3, right? And we want it to end there. So if you can see, the loop goes till the third value, 1 2 3 4. The first number is 1, then comes 2 3 and 4. So if the value of k is 4, we are running the loop till 3. That is why we are here using k minus 1, right? So that was the logic of the loop. Now we have to check if this, that means the next consecutive numbers are available or not. So we'll check if frequency of num plus I, that because that's what we are doing, is equal to 0. If it is 0, that means it is not available and we cannot form this subarray, right? Imagine we are at we have started with 1 and we are currently at 3, that means num plus I is 3, and we are saying that 3 is not available. So the subarray will end at 1 and 2, and that is not of the required length, right? So that means here we cannot form it as form a subarray and will return false. Else the number is available and we'll just reduce its frequency like this. And for after every loop, because we have used up the current number, we'll reduce the frequency of the current number as well. After this, if we have reached the end of the loop, as I said, we'll return true here. We'll return true here. So let's run this loop, I mean the code, and it is working. All the test cases are passing, and let's submit it. And if you see, this test case did not pass. And why is that? That is because if you look at the test case and the one that we use, you see a stark difference, which is this is not sorted while our input was sorted. So we come to this part. Why do we need to sort the array? Because if you look at this example, here I have said that let's say this was the input, and we start from so we start with the initial index 0, then we find 2. If we find 2, the next three numbers will be 3, 4 and 5, right? 2, 3, 4 and 5, and as such we have made the array, right, using these numbers. So then we move I forward. We have used up 3, we move it forward, and we reach 1 after this. When we reach 1 after this, there is no, like, the next numbers are not available. 2, 3, 4 and 5 are gone. 2, 3, 4 are gone, right? We have used it up. That's why we need the array to be sorted, right? We can if we use this input as well and unsorted, right, arrange it in a different manner, we'll see the same pattern, right? Let's say we are removing 1 from here. We're removing 1 from here and we are putting it here, right? Now when I start from here, the same thing will happen, that we'll use up 2, we'll use up 3, we'll use up 4, and we'll use up 5. 2, 3, 4, 5 gone. This array is formed, and after that the I moves forward, this move forward, not available, and reaches 3 again eventually, right? And when it reaches 3, the array it should have formed was 3, 4 and 3, 4, 5 and 6, this second array, right? 3, 4, 5 and 6, but 3 is available, 4 is also available, but there is no 5 available, right? So this will fail at that point. But if you see, technically the input was same, right? I just arranged it in a different way, like I unsorted it, right? And that gave us a wrong answer with the same logic. So that's why we have to sort the array first, so that we reach, so that smaller numbers appear first, and those numbers will be used to start a subarray, right? If you look at it that way also, for every number we are trying to start a new subarray, and the starting of the new subarray has to be a smaller number, not a bigger number, right? So in that logic itself, we can explain that the array needs to be sorted so that we reach smaller numbers first. So I'll just sort the array. Now let's run it again. Of course these test cases will pass, and let's submit it again. And now it is accepted. So that was the solution for this question 1296. It was a pretty easy logic. I'd urge you to see my previous video, because that would make this even easier to understand. That's all for today. Subscribe if you like, if you understood anything, if you like the content. Thank you, and I'll see you in the next one.